Okay, if you missed triangle similarity, this is the video you should be watching. This is page 6 in the binders. This is the first lesson we talked about with triangle similarity. So this stuff right here should look kind of familiar to you from last year. So last year you guys did triangle congruence, where you tested to see if triangles were the same, congruent. This is a little different. We're doing triangle similarity. And so similarity in geometry means that corresponding angles are congruent. That's what I just wrote right there. Angles are congruent. Corresponding angles are congruent. That's that little symbol right there means. It's an equal sign with like a squiggly on top. That means congruent. And congruent means the same. The measures are equal. Okay, and then sides are proportional. Sides are proportional. So that means the sides have the same ratio. So they're either growing by the same ratio or shrinking by the same ratio. And we saw this when we were doing dilations. So our pre-image and our image were always considered similar. The corresponding angles were congruent and the corresponding sides were proportional. We know they're proportional because we were enlarging them or reducing them by a specific scale factor. So everything was growing by the same proportion, the same ratio. Okay, and another thing to point out here before we get into this too far, you'll see these little squigglies after each of these three methods. And so the squiggly means similar. So this is similar by angle, angle, similar by side, 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 and similar by side, angle, side. If we didn't have that little squiggly there, then that would mean congruent by side, side, side. So last year you didn't see the little squigglies there because you guys were doing congruence. But now we have to put those squigglies or else we'll forget we're talking about similarity. So anyway, there's only 3 different ones we have to memorize. So let's start with the first one, angle, angle. And sometimes you'll see this as 3 A's for angle, 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 but it's the same deal. It doesn't matter if you put 3 A's or 2 A's, we're still talking about the same thing. So it says if 2 corresponding angles are congruent, then the triangles are similar. So it's helpful to know about the angles inside a triangle. So no matter what the triangle looks like, if you add up all of the angles, it could be any triangle you could possibly think of. If you add up all of the angles, it's always going to give you 180 degrees. So that's important to know here. Because if you look at example 1, we're missing a couple of the angles. And it's important to know all of the angles to see what's congruent. I mean, just based off these images here, we know, okay, 75 and 75. Yeah, angle A and angle D are congruent. So use those markings to say congruent. But we're provided a 74 here and a 31 here. So we don't have that second set yet. But let's figure out what this one is and this one is, and then maybe we'll have another set that's congruent. Okay, so to figure out this one, well, I know if I add up all of the angles, they're going to give us 180 degrees. So this plus this gives me 180. So to figure out this one, I'm just going to add these two together and subtract from 180. So if I add these together, I get 149. 180, sorry, my cat keeps jumping up here. 180 minus 149 gives us 31. Okay, now we can be like, oh yeah, C and F, those are the same. So that's congruent to that. Notice I'm using 2 markings now. So the 1 markings are congruent and the 2 markings are congruent. And then by the same rationale, we can say, okay, yeah, use 74. So you could do 3 markings up here as well. But remember, for angle, angle, we just need 2 that are congruent. And you should realize if we have two that are congruent, then obviously that last set is going to be congruent as well. But anyway, now we can say these are congruent by angle, angle. Angle, angle with a little squiggly. And then we're going to do a similarity statement. So a similarity statement is going to say triangle something is similar to triangle something. Now I'm going to fill in these blanks here. And it doesn't matter how we start. Like for this triangle, I could say triangle ABC. I could say CAB, CBA. It doesn't matter how we start. It's just that we have to make sure this corresponds. So if I said, I don't know, if I said BAC, triangle BAC, well, what's going to correspond to BAC? BAC. I have to go EDF, right? Because angle B and angle E correspond, right? Angle A and angle D correspond, and then C and F. And you can even use the similarity statement for sides, like side BA is going to be proportional to side ED, all right? Side AC is proportional to side DF. Helps us keep everything in order. And these triangles, you could pretty much tell how to write the similarity statement, but sometimes they'll be rotated, and so we want to know which angles correspond to what, and that helps us do that. Okay. For number 2, you'll notice that now we're missing numbers. We don't have any angle measurements. We don't even have any side measurements. But they do tell us one thing. They tell us V and Y, those angles are congruent. So that's helpful, right? For angle, angle, we need 2. So we got the 1 taken care of. Okay. And I know some of my students were like, oh, well, W and Z, those look like they're 90 degrees. And that might be right, but we don't know that for sure. And a lot of times when we have 90 degrees, they're going to put that little box there. So they could be 90, but we don't know that for sure. We do know, however, that this angle is going to be congruent to this angle. And that's because we call these vertical angles. Vertical angles. And we know vertical angles are always congruent. So they kind of form this X, and like the opposite sides are congruent. Okay, so now we have angle, angle. We have 2 sets that are congruent, so we can say, yeah, these are similar by angle, angle. And we'll just complete our similarity statement. Again, it doesn't matter how we start off. I mean, I could do VXW. But what's going to correspond over here? Well, what corresponds to V? That's Y. What corresponds to X? Well, that's X. And then W corresponds to Z. Okay? If I had done, I don't know, XWV, then that would correspond to XZY. It doesn't matter how we start, it just matters how we finish. Everything has to correspond. So your similarity statement might look different from mine. Okay, so that's angle, angle. I think that's probably the easiest of the 3 methods because a lot of times it doesn't even involve numbers. Angles are pretty easy to work with. So let's move to side, side, side. So for side, 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 we usually don't know anything about the angles. It's usually cases where we're just given the 3 sides, right? Side, 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 side. We just need to make sure the sides are proportional. Then we know they're similar. And this first example is pretty easy. You can probably see that they are proportional. A lot of my students notice that these are, the sides are just being multiplied by 2, right? 3 times 2 gives us the 6, 5 times 2 gives us the 10, 4 times 2 gives us the 8. So yeah, we can see they're proportional, but usually it doesn't work out quite this nicely. So the method I use is I start by labeling each triangle small, medium, and large based on their sides and based on the number. So don't just look at the sides. What's the smallest number? 3. So that's small. 4 is medium. 5 is large. Same deal over here. 6 is my smallest number. 8 is my medium. 10's my large. So if you get some crazy numbers, this little method's going to be really helpful. So to see if they have the same ratios, I'm going to do small over small, medium over medium, large over large. It's going to look like this. For small over small, that's 3 over 6. We want to see if that's equal to medium over medium, 4 over 8. And we want to see if that's equal to large over large, 5 over 10. As long as all of our ratios are the same for all the sides, then we're good to go. And we could reduce each of these fractions. We know it reduced to 1/2, 1/2, 1/2. I like to use decimals because sometimes we get some crazy numbers. So let's see. In this case, 0.5 equals 0.5 equals 0.5. It works out. We can say, yeah, these are similar by side. Oops, sorry. Side, side, side. Side, side, side. If one of these was slightly different though, like let's say this is 0.5, this is 0.5, but this is 0.499999, that does not work. They have to be exactly the same. So rounding doesn't work out here. Okay, so these are similar by side, side, side. Sorry, I meant for that to be an S. And so then we'll just do our similarity statement. So if I start with QRP, we're going to say that's similar to TUS. And again, you could have picked a different one. I don't know, if I said QPR, then that's similar to TSU. There's a lot of different ways that we can do a similarity statement. Okay, so we're gonna try the same thing out for number 4. And you should realize why we're testing side, side, side. It's because we're provided all 3 sides. We can't test something like angle, angle here because we don't know anything about the angles. We have to be provided something about the angles to test angle, angle. If we're provided all 3 sides, then we're going to test side, side, side. So these numbers are a bit bigger, so it's going to be helpful to label these. So that'll be small, medium, large, small, medium, large. I went by the numbers. Okay, and so I'm going to do small over small, medium over medium, and it doesn't matter what triangle you start with. I could have put this triangle on top. I just decided to put that one on top. And then we have 35 over 28. Okay, and these are bigger numbers. I mean, you could try to reduce each of these fractions, but I'm just going to grab the decimal. So I think if we do 30 divided by 24, that's 1.25. And then 32 divided by 25, that's 1.28. And then 35 divided by 28, that's 1.25. So while these are very close, and 2 of them are actually the same, we need all 3 to be the same. This 1.28 is throwing it off. So that means the sides are not all proportional. So that means the triangles themselves are not similar. So we're just going to say NS, not similar. Okay, and since they're not similar, we don't have to do a similarity statement. All right, so let's look at our last one here. Side, angle, side. So for side, angle, side, it says if 2 corresponding sides are proportional and the included angles are congruent, then the triangles are similar. Okay, and so it's, side, angle, side is kind of what it sounds like. If you look down here, we're provided 2 sides and an angle. 2 sides and an angle. So you can read it like side, angle, side. Side, angle, side. And when it says the angles are included, that's kind of a geometry term. That just means the angles are in between the sides. It's in the middle, right? Here's our 2 sides. That's the angle formed by the sides. So that's what they mean by the included angle. So that's required for side, angle, side. And we know we're testing side, angle, side because that's what we're provided, right? Side, angle, side. We can't test side, side, side because we're not provided all 3 sides. We don't know this side down here or this side down here. So we can't test side, side, side. Can't even really test angle, angle. I mean, sure, we know one angle is the same, but it's impossible to tell if J and M are the same and L and P. Just based on what we're given right now, we don't know about angle, angle. So anyway, we're going to test side, angle, side. The angle's already taken care of for us. We know those are congruent, so we just need to make sure the sides are proportional. So I'm going to label my sides again. This time I only have two, so I'm just going to go small and large. So that's small, that's large, that's small, that's large. I'm just going based on the number. And so again, I'm going to do small over small, large over large. So it's going to be 8 over 6, and we want that to equal 20 over 15. So we'll just put this in the calculator. 8 divided by 6 gives us 1.3 repeating. And then 20 divided by 15, it also gives us 1.3 repeating. So we're like, yeah, this is good. These are similar by side, angle, side. And then we'll just go ahead and do our similarity statement. So again, it doesn't matter how we start. I could even start with this triangle. It really doesn't matter. Let's say I do KLJ. That's going to be similar to NPM. Right. And let's look at this last one. This is kind of a crazier looking example. First of all, hopefully you can see the two triangles here. So there's the big triangle, the whole piece, and then there's this little triangle within it. Okay. And then secondly, we have to recognize that we're testing side angle side. It happens to be in this category. And so what is the angle that they have in common? Well, it's this angle right here, angle A. And it takes a minute to see it, but angle A of the small triangle is the same as angle A of our big triangle. So we know those are congruent. And there's a term for that when the angle is kind of right on top of each other, and that's reflexive. So these are reflexive angles. We know reflexive angles are always going to be congruent. Okay, and so now we can just kind of do what we normally do to test and see if the sides are proportional. And if this is confusing with the two triangles overlapping, you can draw them separately. I know some people prefer that. But I'm just going to start by really focusing on my small one here. So just focusing on the small triangle, I'm going to label my sides small and large. So 12 is a smaller number, 15 is the large number. And then I'm just going to focus on my big triangle now, okay? And so 21 is the smaller number, 25 is the larger number. And so we'll do small over small, large over large. So I'll do 12 over 21 is equal to 15 over 25. And this is always the case, but notice that the 12 and the 15, the numerators come from the same triangle and denominators come from the same triangle. Everything has to correspond like that. All right, and so if you do 12 divided by 21, I think it gives you something strange like 0.57, and it keeps going on. And then 15 divided by 25 gives us 0.6. So you can see they're very close, but they are not exactly the same. So this does not work. These are not similar triangles, NS. And since they're not similar, we do not have to complete the similarity statement.